Hello, I'm Drew Patel, and today I'll be discussing Lab 4, which is about circuits. The main purpose of the lab is to explore the concept of loop rule and observe current to predict the behavior of circuits with resistors and capacitors. The main fundamentals that we're going to be looking at in this experiment will be Ohm's law, circuit rules, energy conservation, and series in circuits. So here's the experimental data after setting up the online simulation with two batteries, two resistors, and two ammeters on each side. I was able to measure the current to be about 0.02 on both sides. And then in experimenting with the emitters, replacing one of the emitters with a voltmeter, it still resulted in a closed circuit with voltage the same, measuring as such on the resistor. In turn, the net voltage is zero throughout the circuit. Similarly, measuring the volts at different points, we can ideally predict that at the first resistor with this 47 ohms, the volts reduced by 0.96 volts, and the second resistor by 2.04 volts, resulting in net zero for the rest of the circuit. Now, more experimenting with the circuit, having only one of the resistors, the current measures to be around 0.06 when replacing the 100 ohm resistor. And although calculating resistance from the previous part results in these values, they're miles apart from less resistance in the current circuit. Now looking at RC circuits, this one is an RC circuit with one light bulb attached to an ideal battery and capacitor with a wire, producing the result that the light only stays on for a short amount of time. And likewise, removing the battery from the circuit also creates a spark of light for a short amount of time when the capacitor discharges. The time it takes to charge and discharge the capacitor for a light bulb with difference in ohm is shown by 5 seconds difference in time when raising the ohms 10 ohms for the light bulb. Basically, the higher the ohms for the bulb, the longer it takes to charge and discharge. Continuing the experiment with this time 30 ohms of the light bulb, this produces the graph of the data where it is represented by the natural log of that data, and it gives us the slope of negative 0.1866, and that will also help us get the RC value, which is 5.36. For the what if questions, how would an actual emitter in real life change things? Well, the difference is that the real emitter would have some resistance within it, while the online emitter is the ideal emitter with no resistance. The second one, how would a real battery change the results? It's pretty much the same concept where there would be some resistance, but also it would take longer to charge and discharge. So thank you for watching.